So let's start off with just getting to a cancerous cell, just kind of a recap on what we talked about yesterday. So here, let's just title this thing in the top middle, Cancer Spread. Very uplifting topic for a Friday morning. Okay. So let's start up here in the top left corner. At least that's where I'm going to start. You have a ton of space, so you can kind of orient this however you want. But we are going to go with cells can become cancerous when the genes which code for regulatory proteins become mutated. Remember that the regulatory proteins are the proteins that are in charge of regulating the cell cycle and making sure that they progress through that series of checkpoints that are required whenever a cell is being ready to divide. There we go. Okay. So there were those three different types of genes here. We had the tumor suppressors, and the oncogenes, and genome maintenance. So those are those three different types of genes that we see, and whenever we have a combination of these genes being mutated, the cell cycle will undergo all these checkpoints, and we can end up with a cell becoming cancerous. So this gets us to like one cancerous cell, essentially. Okay, so we have this one cancerous cell, and it is going to start to divide and divide and divide. So eventually, you got to think, what do cells need in order to stay alive? What are some things that cells need? They need oxygen, okay? They need glucose or some form of fuel, and they're going to get that from the bloodstream. But if a tumor starts to get big enough, then there are parts of that tumor that are going to be too far away from the capillaries that fed the initial cancerous cell, and they're going to require more nutrients in order to stay alive. So this process is called angiogenesis. So let's go ahead and put in a blood vessel here in the middle. I'm going to do it here. Okay. Well, yours is really big, so you probably don't need it to go that far. But it can if you wanted to. Depends on how big you want to make this thing. I'm using a small one just so it fits on my desk here. Okay, so here's a new term that you may have heard before, but we never actually talked about. So it's called angiogenesis. Angio means vessel. Genesis means creation. So this literally means vessel creation. And what we end up seeing are a couple main points. So as the tumor grows, the cells require more nutrients. So what's going to happen is that these cancerous cells are going to need more nutrients, so they are going to start to recruit blood vessels to come into them. So essentially what we see is that cancerous cells act almost as parasites. And what I mean by that is they're going to be siphoning off a blood supply from healthy tissue within the body. And as they grow, they're going to require more and more and more blood. Okay, so let's kind of draw out what this would look like. So you can imagine in our blood vessel here, we would have blood and nutrients going through this vessel. Okay. And let's sketch in here a couple cells. So we have, here I'm just going to do it this way. I'll show a tumor that's formed. So maybe there's a tumor here. And this is all made up of cells. Apparently these are weird, varying rectangular cells. So you can draw your cells whatever shape you want. The world is your tumor. So there is our tumor. Maybe this was the original cell. I don't know. But you have to imagine that our cancerous cell started to divide and divide and divide, and every time that it divided, it was passing on the same mutations that caused it to be cancerous in the same place, or in the first place. Okay, so here's what we see with angiogenesis. We are going to end up with a blood supply being formed to the tumor. So in angiogenesis, we have blood vessel recruitment. Towards the tumor. So it's going to branch off of an existing blood vessel, is what we'll end up seeing. So if this was the original blood vessel, we would have the blood supply branch off of it, and it will start to wrap around. It doesn't just like plug into one of these cells, it actually forms capillaries all the way around this thing. It will surround it and supply blood in all three dimensions to this tumor. Now, the way that these cancerous cells do this is by manipulating a hormone that that is used anytime that a blood supply is produced. And this hormone is called VEGF. So let's look at how this happens. This is going to get a little more technical than what we need, but it'll still be something that is good to know. So what we see with angiogenesis, so I'm going to put down here that we are again talking about angiogenesis. Okay. Vessel recruitment. Is achieved by the release of specialized proteins. And these specialized proteins are called VEGF. VEGF. And that stands for, and again, you don't need to memorize this or anything, but might as well tell you, stands for vascular endothelial growth factor. So that's what VEGF stands for. So it's a specialized protein, and it is going to recruit blood vessel formation down towards the actual tumor itself. So It stimulates blood vessel growth towards the tumor. Okay, so imagine that these cells are beginning to become starved of oxygen. They are going to start releasing this VEGF, which I'm going to show as being little triangles, because why not? So we have all of these VEGF triangles being released. And these proteins are going to stimulate blood vessel growth in the direction that these VEGF proteins were released. And this protein is used in normal blood vessel formation. This isn't like some special thing that cancerous cells made up. This is something that naturally exists in our bodies, but it is this process is hijacked by these cancerous cells. So now what we'll see is that blood and nutrients are going to be able to come right in here, and we'll start to give these cancerous cells their own blood supply, which is going to allow them to grow even faster, because now they have pretty much an unlimited supply of nutrients and oxygen. So now we will get even faster cell division than we did before. Okay. So this will increase cell division. We will see increased cell division within the tumor. Okay, now, it wouldn't only form like one port into the tumor. There would be a multitude of these things that are all linking in and surrounding and wrapping around this tumor site. And this brings us to our next process. So there was angiogenesis, and now our next process is how cancer actually spreads. So this is how it gets bigger, and now we're going to get into how it actually spreads, and that is through metastasis. All right, we'll do this one over here. So meta means beyond. Stasis means location. So metastasis means that something has gone beyond its location, essentially. And what we see here is the movement of cancerous cells away from the primary tumor. The primary tumor is just the first tumor to develop. It will contain the original cancerous cell. So this tumor that we just drew in right here would be our primary tumor. So all I did was just label that as primary tumor. Okay. The way this happens is it is going to move, actually sorry, cells can break off of the primary tumor. As these tumors get bigger, they get more and more unstable. And as they get unstable, there's a likelihood that cells that are dividing off of these cancerous cells will break free from the tumor. And enter the vessels created in angiogenesis. Where they will spread anywhere the blood goes. Where does blood go? everywhere. Yeah, so this is where you can end up with cancer that originated in one part of the body spreading to a completely distant location. Because once these cells enter the bloodstream, they can pretty much go anywhere. Now, this doesn't have to only happen through blood vessels. We'll talk about here in a second how they can also go through lymphatic vessels as well. But basically, if we were to draw this occurring, we would see as this tumor is growing, the tumor becomes more and more unstable, and cancerous cells can enter the blood supply and be spread. Now, what's going to happen is eventually they'll get embedded into a new location. So we could see them coming in here and maybe like embedding up here in this wall, and we will end up with secondary tumors forming, and then we could have tertiary tumors forming, and quaternary, and so on, as this cycle just repeats and repeats and repeats. So let's add that in. As cancerous cells metastasize, secondary / tertiary / etc., because you can just keep going, tumors will form. And this just turns into a positive feedback loop, because the more tumors you have, the more cancerous cells you're going to have, and the more likely that the cancer is going to spread to another location, which sets up another tumor, and the whole thing just keeps on spreading that way. Okay, so you could imagine then that maybe up here we would have a secondary tumor form. The secondary tumors will typically be smaller than the primaries because they haven't existed as long. So there's been less time for cell division. But you could imagine that as they grow, they will also require more nutrients and more energy, so they could start releasing this VEGF as well. And we will get blood vessel recruitment. And then possibly metastasis. And that's how we can have a secondary tumor breaking off to then form a tertiary tumor. So this here would then be our secondary tumor. So the last thing I want to add at the bottom of metastasis then is that this creates a positive feedback loop. The last thing I want to add to this is that this process doesn't have to just happen through the blood vessels. It can also happen through the lymphatic system. So not only do we see angiogenesis, but you could also end up with, this is a weird word, lymphangiogenesis. Which just means the vessel creation within the lymphatic system. So your lymphatic system is an accessory system of your immune system. It drains fluid, but it also has vessels that go through your entire body as well. So if cancerous cells enter your lymphatic system, then we can have the exact same process occur just within the lymphatic system. So here, this would be creation or recruitment of lymphatic vessels. So maybe we have a lymphatic vessel right here. we would see vessel recruitment just like we did in angiogenesis, and we could end up with, we'll do it over here, lymphatic vessel recruitment, and then possible spread through the lymphatic system as well. So it doesn't just have to be blood vessels, it could be through the lymphatic system also. Okay. So to kind of recap, cells become cancerous whenever they have genetic mutations impacting the proteins that regulate their cell cycle. Once a cell becomes cancerous, it is going to experience a rapid, uninhibited division. And as that cell divides and divides and divides, we can end up with a primary tumor forming. As the primary tumor gets bigger, it's going to require more nutrients because there's more tissue to feed. And in order to get those nutrients, these cancerous cells will perform angiogenesis, where they are going to be recruiting blood vessels to form off of neighboring blood vessels and directly link in to the tumor, which is going to supply an unlimited amount of nutrients to that primary tumor. As the tumor gets bigger, then it becomes more unstable, and cells have a likelihood of breaking off of that tumor and entering the original blood vessel that the tumor recruited off of. And as soon as that cancerous cell enters the bloodstream, it can be transported anywhere. And we call this metastasis, and this is how you end up with cancerous cells going from their original tumor site to a new tumor site. So this cancerous cell here would break off, enter circulation, it would get lodged in some other tissue somewhere else in the body, and then it will start dividing itself, setting up a secondary tumor. As the secondary tumor gets bigger, it will also perform angiogenesis, and this is how we can end up with a tertiary tumor and then a quaternary tumor. And you got to think that now you have two tumors that are producing metastasizing cancerous cells instead of one. So this creates a positive feedback loop. The more tumors there are, the faster it spreads. And then not only do we see this happening in the blood vessels, the exact same process can happen in the lymphatic system as well. And sometimes you can have that happening in both. It just kind of depends on how far things have progressed. Most staging systems, like whenever you talk about what stage a cancer is in, is going to be based on how many different tumor sites there are compared to the original primary site. All right, I think that covers angiogenesis and metastasis as far as we need it. Questions? What do you think?
So does everyone who gets cancer have a tumor?
Not necessarily.